solve.
Mm-hmm.
They just are. You don't have a cubic formula like you have a quadratic formula. So solving a cubic is a big, big deal. And one of the best ways to solve it is to use your calculator. But in this particular case, he's saying your trace, zoom, and window are not working. And therefore, what you're looking at, you have no idea how close you are zoomed in or zoomed out.
Mm-hmm.
And therefore, he wants you to, from the graph, what appears to be an integer solution to the equation. Well, the other thing on this graph is it doesn't have a grid line marked up, so I can't tell how many each grid is, but from number C, it's clear that every grid mark is 10 units. You see why?
Yeah.
Okay. Because they're telling you that x equals -7 is a solution. Since x equals -7 is a solution to the equation, what is the factor associated with this solution? Well, we'll get to that in a second. But they're telling us, you see that point where I'm pointing?
Well, wouldn't it be the other point, like the far left point on the x-axis?
1, 2, 3, 4, 5, 6, 7. You're absolutely correct. In other words, there appear to be 3 x-intercepts, which is what you would expect.
Yeah.
-7 is going to be one of them. And the other 2 are probably going to be irrational numbers. In other words, that falls in between 0 and -1. And that falls in between 2 and 3. Well, I thought that was -7, was because it looks like it would be -7 if every grid mark was 10. But you're right. All 3 of these lines that cross the x-axis have to be zeros. So when they say, what is the integer solution? Well, clearly that one and that one is not an integer solution, but that one is. In other words, there's your -7. And you can prove it by putting in -7 into the equation and making sure that it says 0 equals 0. Okay? And you know how to do that, right?
Yeah.
We don't have to go through that arithmetic.
Just plug it in for x.
Yeah, you plug in -7 for x. And if you still have 0 equals 0, well then -7 is a solution. Okay, now because -7 is a solution, what's the factor associated with that?
How would you solve that?
Okay, let me ask you another question, and as soon as you answer this one, you'll be able to tell me. Here are 2 factors that multiplied together are equal to 0. Tell me what the solutions are.
Oh, 3 and -2.
So if you start with the solutions first, what are the factors?
Oh, so it'd be x plus 7.
You got it. In other words, always remember what you're doing. You're just going backwards. Most all math, wants you to be able to go forwards and backwards, okay? use polynomial division to find the other factor. Okay, well, what they mean is long division. They didn't say synthetic. You've learned synthetic division?
I don't know.
You don't know? Okay. Well, they haven't asked about it so far. So
Yeah.
polynomial division means we are going to take our one known factor and we're going to long divide it into the polynomial. And this is actually easier than it looks. And notice what we're going to get as an answer. We're going to get a quadratic, right? In other words, if you start with a cubic and you divide it by a linear, then you end up with a quadratic. Now, do you know how to do this division?
I think we might have gone through it once, but vaguely.
It's pretty easy. Let me just give you once you do it once, you divide that into that. What do you get?
X squared.
That's first step, always. Now, you take that and you multiply it by both terms. What do you get?
X cubed plus 7x squared.
And now you do just like long division, you subtract.
And then you get negative 2x squared.
And now you bring down the next term.
Minus 16x.
Now you repeat.
And you divide by
X into that. In other words, your very first step is always to divide just the variable into that variable. Then you take your answer and you multiply it by everything.
Yeah.
So multiply it by everything, or excuse me, divide it. We're into this step where you're dividing that into that. What do you get?
Then you get negative 2x minus 16.
Hold on. No, you don't. In other words, your first step is only dividing that into that. You don't divide it into everything.
Oh, yeah.
The first step is you only divide the highest term variable into the highest term variable. And you'll see why in a moment. Now take your minus 2x, multiply it by both terms. What do you get?
You get negative 2x squared minus 14x.
Okay, now subtract, just like long division. What do you get?
Then you get negative 30x.
Hold on. What's minus 16x minus a minus 14x? Do not drop negative signs.
Negative 2x.
The biggest mistake made in algebra is dropping negative signs. People want to do it. People hate negative signs. You give them an expression that's got 3 negative signs in it, they're going to say, crap, I hate negative signs. Let's get rid of some of them. Let's drop one of them. That seems to be the way people proceed. Well, you can't do that. You drop one negative sign, you're getting the wrong answer. So negative signs are every bit as important as positive signs or anything else in math. You can't drop anything. Now, you got minus 2x. What's the next step?
And you bring down the negative 14.
Okay, and now repeat.
And you divide by the x plus 7.
Nope,
So then you get,
just divide by the x. Remember, you're only dividing the x into that. That's the only thing you're doing for step 1 each time.
Right, so then you just get negative 2.
Okay, now multiply the negative 2 by both terms.
Then you get negative 2x minus 14.
And the fact that you get a 0 when you subtract those two confirms to you that x plus 7 is a factor of this cubic. If it was not a factor, you would not get a 0. You would have some remainder that was not 0. That, in fact, is a theorem all on its own. You've maybe had it. It's called the zero factor theorem, which means when you take a known factor, we know that x plus 7 is a known factor of this cubic, and if we divide it, we better not have a remainder. If we have a remainder, then x plus 7 is not a factor. Okay? Yeah. But that's how you do the long division. So what we're left with is this. That's one factor. In other words, whatever we got when we divided it, right? In other words, if I multiply x plus 7 times that answer, I got to get this, correct? If I divided x plus 7 into that to get that answer, then it's got to work the other way around also.
Yeah.
So those are my two factors right there. One is a quadratic that I can still solve. And in fact, if I look at their graph, I know I have two other solutions. Here's a solution right here, and here's a solution right there. So I don't have imaginary solutions. Imaginary solutions don't cross the x-axis. So I have to have real solutions. Okay. Now, it says, okay, so we just found the other factor, number D. Now, use your new factor to complete this equation. Well, what it is right there, equals 0. In other words, F. There's my x plus 7. The other factor is what we got when we did the long division. We got x squared minus 2x minus 2.
Yeah.
Now, the other factor leads to two other solutions. In other words, the key principle here being that if you're multiplying two things together and they're equal to 0, well then either that's equal to 0 or that's equal to 0. Well, when I set the first one equal to 0, I got my x equal minus 7. So I already know that's one solution. I don't need to worry about that, but we do need to worry about this. So we're going to set this equal to 0 and solve it. Now, if we take a look at the graph, we can see we don't have nice round numbers at these 2 points, right? Yeah. So immediately I know I'm not going to be able to factor that. There's no way I'm factoring it. I got to solve it with the quadratic formula. I'm going to get two real answers, not imaginary. You've had imaginary numbers, right?
Yeah.
I'm going to get two real answers, and the only reason I know that is because I'm looking at x-intercepts right there and there. And guess what? Imaginary solutions do not cross the x-axis. So the fact that I'm looking at two x-intercepts means that these have to be real solutions. Well, I'm going to have to solve it using the quadratic formula. Tell me what that is.
Well, I should know.
I know that is, first of all, I can see that this is not factorable. But more importantly, I can see from the graph that I don't have integer solutions. So I'm pretty sure it's not factorable just from that. So I immediately go to the quadratic formula. I do not even bother trying to factor it. Okay? All right. So what's the quadratic formula?
Oh, I should know this off the top of my head, but I'm spacing it out.
Yes, you should. And in fact, you need it for the SAT test. They don't give it to you. This is definitely a formula you need to memorize. When you get to college, you'll need it. I'll give it to you now. minus b plus or minus the square root of b squared minus 4ac all over 2a.
Yeah.
Now, let me give you a little bit of tips. Notice the first part of this. What is that?
Oh, I can't see.
Find the x-coordinate of the vertex of a quadratic.
Yeah.
Minus b over 2a. So always remember that when you're trying to remember the quadratic formula, the first half of it is the same as what they taught you how to find the vertex of a quadratic. If you gave me this quadratic, x squared minus 2x minus 2, and asked me the vertex, I would immediately do minus b over 2a. That's going to give me the x-coordinate of the vertex.
Yeah.
No two ways about it. Okay? So that's a really important formula to remember for the vertex, and it's half of the quadratic. And then the plus or minus isn't hard to remember. There are not very many formulas that have a plus or minus in them. And then the b squared minus 4ac, that actually has its own name. And I'm sure you've been taught this. That is called the determinant, or excuse me, the discriminant. A lot of times when you're looking at a quadratic, you want to know whether it has real solutions or imaginary solutions. So what you do is you analyze that first off the boat. Well, when I analyze that, I get 4 minus 4 times 1 times minus 2. That's 4 plus 8. That's 12. That is a positive number. That means I have real solutions. Had that been a negative number, I would have had imaginary solutions. So this thing called the discriminant is really important in math, all on its own, separate from the quadratic formula. Because this tells you whether you have real solutions or imaginary. We can see from this problem that we have real because it crosses the x-axis. 3.
Yeah.
But so we already knew that was positive, but then when we actually do the numbers, we get a 12. But my point being is that if you're trying to figure out a way to memorize the quadratic formula, think of it as two different things. Think of it as the first part is the formula for the vertex, and the second part is the square root of the discriminant. Notice the discriminant is not the square root of b squared minus 4ac. The discriminant is the b squared minus 4ac. This is the discriminant.
Yeah.
That's very important to know what that is and why it's important. And once you memorize what the discriminant is, then you probably will never ever again forget the quadratic formula. And the only thing more important than the discriminant to memorize is the quadratic formula. I mean, you're going to be tested on it. You really are. So you got to know it. I know some schools teach a song, kind of like ABC song. You know, I don't know if I would know my ABCs today if I didn't sing the song.
Of b squared minus 4ac all over 2a.
Yep, I've heard that before, and I tell you what, whatever it takes.
Yeah.
If that's what it takes, then do that.
Yeah.
If you told me which came first, J or K, I would have to sing the alphabet to answer that question. Serious. I would have to say A, B, C, D, E, F, G, H, I, J, K. Okay, K comes after J. But the fact is that I don't memorize it any other way but the song.
Yeah.
Which is unfortunate sometimes, but it doesn't matter. If you have a song to memorize something and you have to be able to memorize it, then you use the song.
Yeah.
All right. So the other factor leads to The other factor being this factor right here, x squared minus 2x minus 2.
Yeah.
And it leads to two other solutions. Well, of course it does. The quadratic formula produces two solutions. Find these two solutions. Okay. So first of all, tell me what A, B, and C are.
So y is equal to x squared. So then a is 1.
Okay.
And then b is -2. And c is also -2.
Now you just plug those in.
Yeah.
So what are my other two solutions?
So then x is equal to 2 plus or minus the square root of 4 minus.
I recommend writing this out every time. Do not do this in your head.
Yeah, -4.
Only because it's so easy to make a mistake. It is really easy to make a mistake there. For one thing, you're looking at a subtraction sign there and a negative sign there that can be misinterpreted as subtraction.
Mm-hmm.
So the way I tell everybody to do these, and it's all over too, but the first step in solving that is to solve those three numbers right there. Subtract your answer from the number 4. Well, those three numbers are -8.
Mm-hmm.
Now you have 4 minus -8. Again, do not drop a negative sign. So my answer is 2 plus or minus square root of 12 all over 2. Now, can I simplify that? The square root of 12, can I simplify that?
3 and 4 is 2, so that's 2 squares to 3.
And that's real important. Notice what that allows me to do. That's my answer, and now I can divide top and bottom by 2, and I get the proper answer, which is 1 plus or minus the square root of 3. And that's what these 2 points are. Notice that one of them is the negative. If square root of 3 is about 1.7, so if you had 1 minus 1.7, you'd end up at minus 0.7. You can see why I thought that was 7.
Yeah.
It is actually minus 0.7.
Mm-hmm.
And then the other answer is 1 plus 1.7. So the other answer is 2.71, which is that one right there.
Yeah.
Okay. So that was a lot of work, but it should have been pretty instructive.
Mm-hmm.
In other words, there's not very many questions that have 7 questions as part of them. And this is a little clever in the fact that they made up this scenario where your trace, zoom, and window don't work, which means you can't zoom out. If you were able to zoom out on this thing, it would probably look like this.
Yeah.
That's what a cubic looks like. But when you're zoomed in, is all you see is that. So if you can't zoom out, it's much harder to see what the graph looks like. But that's part of the secret of this problem is that that's what they're trying to do, is to get you to figure it out without being able to zoom out.
Mm-hmm.
All right, is 8.121, is that on another page, or is that one we need to do?
That's the next page that I emailed you.
Okay, let's go find it. That's 8. Okay, I got it. I don't see 8.21 on there.
I think that it's just 8.22. Like, I only screenshotted the ones that I wanted to go over.
Okay, so you want to do 8.122 next?
Yeah, and then I only have a couple more minutes here before I have to go to my track meeting, so.
You tell me when you got to go. I see it's 6:27. So you tell
Okay.
me. I'll get through as many of these as I can.
Okay.
This is a good one. I love this stuff. This really, really does test your understanding of it. Much more so than most homework would. I love it when it says without actually multiplying. Okay. That's really going to test your understanding of it. So, could this be the answer?
No.
No, because I know that in the end, the first term is going to be x times x times x.
Yeah.
So I can't have a 2x cubed as the first term. I got to have an x cubed. Now, the last term is going to be that number times that number times that number. So what is our
That'd
answer?
be 6. Oh, would that be a negative?
Just worry about the number. Don't even worry about the sign.
That'd be 30.
That's got to be the answer.
Oh, yeah, yeah.
That's the only one that's got an x cubed at the beginning and a 30 at the end.
Yeah.
Okay, again, you tell me when you got to leave.
Okay.
Which of the following could be a factor of that cubic? You apparently have had the rational factor theorem,
Yeah.
which tells you that if there is a rational factor to that cubic, its numerator's got to be a factor of 5, and its denominator's got to be a factor of 1. So I don't have many choices. I got plus or minus 5 for the numerator and plus or minus 1. Those are the two factors of the constant. And in the denominator, I just got plus or minus 1. So my only answers are plus or minus 5 and plus or minus 1. So which answer is correct?
B.
It has to be. There's no 2's
Yeah.
and 3's in there. So
Yeah.
merely by knowing the rational factor theorem, it allows you to solve that. And that's not easy. Rational factor theorems usually are like 20-minute problems, as you've seen. You think quadratics are tough. At least there's a quadratic formula. There's no cubic formula. So there's no way to do cubics except by this really, really tedious method where you figure out all the possible rational factors and then you check each one of them to see whether it could be right. Well, the only one that can possibly be right is the one that's got the minus 5. There's no.
Yeah, okay. I think that I have to head on over to my track meeting.
Okay, no problem. Blake,
Okay, thank you.
talk to you next time.
Okay, thank you.